Attributes of elementary entity like spin of the electron, spin of other particles, polarization of the particles, and they have different characteristics. So the question is how these attributes are coming from the seed or potentiality of this substratum. This is very challenging questions, and scientists are struggling to understand how from simply attributes in very abstract terms, how we will get the physical attributes of this universe. And before going into that, let me tell you one more thing which is very important in this kind of debate with Buddhist philosophy. According to Nagarjuna concept, as far as you understand, at the ultimate level, the objects don't have svabhava or intrinsic properties. Now, as Professor Chaudhary also mentioned, that there are a class of particles which we call fermions, means a class of particles which have spin half or multiple of half, like 3 by 2, 5 by 2, etc. They follow a certain distribution pattern, and this was discovered by famous physicist Enrico Fermi. We say fermions. There is another group of particles called bosons, like photons, which have spin 1, or there are spin 0 particles, integral spin, and they follow a particular distribution discovered by famous Indian physicist S.N. Bose, and then later elaborated by Einstein. We say Bose-Einstein statistics. So the question is whether the spin are the intrinsic properties of this elementary entity. If you go to any standard textbook of quantum theory, they start with intrinsic and extrinsic properties. If they are intrinsic properties, then how do you reconcile with Buddhist philosophy? They say on the ultimate level, no entity has svabhava or intrinsic property. But you need to understand more to go into this debate. Here you see that what experimentalists they got it. Here a proton or a pi meson, a kind of elementary entity, collides with a silver or bromine nucleus of the emulsion and produces high energy secondary particles, lot of secondary particles. And also here it produces lot of secondary particles. Now here, creation of particles in the vacuum. Say there is a vacuum, as I told you, because of the fluctuation from photons, the light quanta gives rise to electrons and positrons. Okay, what's the fun with that? Photon has spin 1 which obeys Bose-Einstein statistics, and they are called intrinsic properties of the boson. Now we are getting fermions out of that. Fermions, electrons and positrons, they obey a different statistics called Fermi statistics. So we are starting with a boson which have intrinsic property like spin 1. Out of that we are getting bosons which have within quote intrinsic property called fermions. So you can ask me, if it is intrinsic property, then how this intrinsic property comes from another intrinsic property? Or really, can we think in terms of the intrinsic property, or they are not really intrinsic property? I think this will shed a new light on the debate whether quantum particles have intrinsic property or not, which is directly related to Buddhist paradigm. Yeah, I have written two important questions. Where are these particles before they become manifest? I mean, there are photons, there are no electrons and positrons, no fermions in the beginning. But out of the fluctuation, these photons gives rise to fermions. So, where are these particles before they become manifest? Did they exist as such, or were they created? How they get the specific properties or attributes like mass, charge, because you know electron has a definite mass, definite charge, definite spin. So how we can get it? If we can get through interactions, then they are not intrinsic property.